Great.
My name is Mark Lepetis, and I'm the semiconductor editor of the E-Times, and we're here at San Francisco at SEMICON West for the first day here. And standing to my left is Jim Clifford. He's the Senior Vice President, General Manager of Qualcomm CDMA Technologies, which is part of Qualcomm Incorporated in San Diego. And Mr. Clifford today will be giving one of the keynote addresses today. And Jim, thank you very much for your time here. And we're trying to get an idea of if you could give us a glimpse of what you might be saying today during the keynote.
So my talk today is really about change. It's changing models in a changing landscape. And it'll go to what are the key drivers for semiconductor technology going forward. In the past, it's historically been computer, which is driven by memory, which is driven by DRAM. And now, of late, we see the emergence of both consumer and communications playing a predominant role. So in the future technologies, I think people like us, like Qualcomm, that are very big in the wireless space, driving communications and consumer electronics, will play a more significant role in specifying what the future technologies are. So that'll be a predominant part of the talk because I'm speaking to semiconductor folks. And we also want to talk a little bit about integrated fabless manufacturing, a shift in the business model from IDMs to fabless to fab light, and how integrated fabless manufacturing works for us, what its advantages are, and bringing products to market sooner to make our customers successful. So those will be two of the big themes in the presentation this morning.
Right, and within that framework, today you made, that's Monday, a fairly significant announcement with IMEC regarding in the field of 3D packaging. And what kind of role will that play at Qualcomm?
So 3D packaging, when we look forward, is a real critical technology for us to bring to bear. Today it doesn't really exist. But the ability to stack multiple wafers on top of each other and interconnect them with thousands, literally thousands of vertical connections, offers system architects an opportunity that's not existed before. We've migrated from wire bond to flip chip, and we use very complex packaging technology today. But within a few years, as we bring 3D stacking through silicon vias and 3D stacking to the marketplace, I think a transformation which has not been seen before will take place. The freedom that architects have will be enormous, but it requires a very broad infrastructure, and that requires people like the CAD tool providers to do simulation, route and place in 3 dimensions instead of in 2. And both the foundries and the packaging teams, as well as the system designers, to collaborate, work closer together than they've ever done in the past. But I think the results of this will provide products that will just blow people away 3 to 5 years down the road. And as you can tell, I'm very excited, and Qualcomm's very excited to participate in these changes.
Now, you mentioned during the interview earlier about the CAD tools. How far along are we in the CAD tools to enable this?
I think CAD tools today are very good in digital chips. They need some enhancements in the RF and analog area. But as far as packaging, I think there's a lot of room for improvement. Up until now, we've treated packaging as a shell to hold a die. It's a space transformer, it's a heat conductor, and it's a protective environment. But now and going forward, packaging is an integral solution. It is a part of the system. So extracting the parameters necessary to do top-level simulations and making sure that route and place lines don't run parallel to each other, like receive and transmit lines for coupling. I think these are going to be more important. So I think there are big opportunities for the EDA tool vendors in this next few years to develop the tools that will allow the architects to partition a system and ensure that designs work either the first time or very close to the first time. So a lot of learning to take place, but again, I'm sure they're just as equally excited as we are. And IMEC will be a good partner to us because they have relationships with not just the equipment manufacturers, not just the university, but also the EDA tool vendors and the assembly folks and the entire infrastructure. So I think it's a good partnership between us and them, and I think should bring some exciting products to market.
And last but not least, you were talking about the true full silicon enabling era where we're going to see who will lead in terms of via first or via last, and explain which some of the trade-offs in that particular, those two particular camps?
So I think first to define the two, via last is having the assembly folks drill the holes through the silicon, and via first is having the foundries drill the holes through the silicon. And I think it may sound trivial, but I think the plan is to have via last come first and via first come last, because the complexities in the silicon are very, very daunting. I shared with Mark that if you were an electron on a digital baseband chip and you had a choice of going 1 millimeter horizontally through a 45 nanometer wire or going 25 microns vertically through a 1 micron copper pipe, I think if I were an electron, I know which way I'd rather go. So I think that's a terribly important aspect to it. So the VLAS technology, I think, will work for at least for memories, broad bandwidth memories, trying to interface with digital baseband chips. That's probably a very good application for it. Things that require maybe 500 interconnects, somewhere between 100 and 1,000. But I think when you really want to take advantage of through silicon vias and through silicon stacking, 3D-dimensional stacking, I think you really need vias on the order of 1,000 to 10,000. And although it's hard to define who's going to need 10,000 vias today, we've had a habit of consuming everything that technology has been able to provide in the past. So I expect there to be some very exciting applications and very creative people that figure out how to use all the vias that we can put and the ability to stack these multiple technologies together.
Very good. Jim, thank you very much for your time. Thank you for the conversation, and have a good week. Thanks very much.